In this example, we see return loss fail, and the red asterisk at the side here indicates that it's a very small fail, but within the accuracy of the instrument. However, a fail is a fail, so we need to diagnose it. If I tap on return loss, the test is going to automatically go to the end where that worst failure was, and it's detected that the measurement from the near end, not from the far end, is where our worst performing return loss measurement was. If we tap next to pair, the tester is going to automatically go to the worst performing pair 7/8, and that's important to remember in a moment. Now, if you see my DTX videos, you'll know that I say, well, if it fails at the lower end of the frequency range, 50 megahertz or less, that tends to indicate a cable issue. When you look at this one here, it's actually failing at 117 megahertz, not exactly the low end of the frequency range. However, there is something to be told about this screen here, because when you look at each side of the cursor, the rest of the frequency response is actually passing, it's above the test limit with good margin. It's just happening at this one frequency point. When you see a return loss fail at a single point frequency like this and everything else is passing with good margin, that's an indication of a cable issue. If we go and look at our other pairs like 3/6, we got good margin, 4/5 is good margin, but also 1/2 barely passes. But like I said, we'll focus on just our 7/8 at the moment, the failing pair. So let's go back to the home screen and go to our diagnostic. Now we got two options in here. We have our high definition time domain reflectometer. That allows us to look down the cable and see where the impedance anomalies are, ideal for troubleshooting return loss. And then we have our HD TDX, X being crosstalk. Since we want to diagnose return loss, we'll go to HD TDR analyzer. And we're going to go and look at our pair, 7/8. I'll tap that until I see 7/8 in the top left. And what I need to do is I need to zoom in. Now, how far do you zoom in? I like to zoom in just to the point where the half dB, the half percentage point appears. Let me just move that across there so we see the whole thing. Okay, when you look at a trace like this, it can be initially intimidating. You're looking down the cable and seeing where the impedance anomalies are. And just like the DTX cable analyzer, what you're looking for, hopefully, are no events in the cable that exceed 0.8 or minus 0.8%. Let's go ahead and magically put in 0.8. and minus 0.8 here. And what we can see is we have multiple events exceeding 0.8, our guide. So that confirms our suspicions that since it is happening in the cable, we have a cable issue. Now, whose fault is this? Did the installer do this, or was this cable badly manufactured? This is one of those occasions where it's really tough to tell, but what we do know for sure is this cable, unfortunately, is going to have to be replaced. Let me go to that orange pair. Remember that orange pair didn't look too good either? Well, look at the TDR response. Again, it doesn't look too good, but the other pairs did pass with good margin. So when I look at those TDR responses, I see a very different trace, a lot cleaner. Not even close to my 0.8%, my minus 0.8% guide. And again, I can look at the other pair as well. Of course, somebody might spot this here, this little spike here, and indeed I can move my cursor to that location. Let me fine tune that. And around about 7 meters, 23, 24 feet, it's found an anomaly that exceeds our 0.8. And now this is very important. In the real world, outside of a laboratory, things happen to a cable, and you are going to get 1 or 2 events that exceed that 0.8. That's not a reason for ejection. In fact, if you do, the chances are your return loss measurement is still going to pass with good margin. It's when you start seeing the events exceed 0.8 on multiple occasions, that's when you become the point of concern. So that's how you diagnose a return loss failure caused by cable.